Hello, everyone. My name is Andrew Koeser. I'm a professor and researcher at the University of Florida Gulf Coast Research and Education Center, located near Tampa, Florida. I was contracted by the Florida Department of Transportation to do two things. The first was to revise their existing guidebook for the pruning and maintenance of woody plants, particularly trees and palms. And the second was to do a research project on the planting success of their previous Bold Initiative landscapes. We did that, and I worked very closely with a student, Seth, a past master's student of mine, and this was his master's work, where he took your survival and establishment results and compared them to other projects both within the state and beyond. And I'll show you in this presentation that you have a lot to be proud of with what he found. So with that, we're going to go on. This is called Bold Initiative, Big Results, Recent Findings from an Assessment of Tree Installations for FDOT. This is an example of one of the plantings that we looked at. FDOT has been really a leader in planting trees in the state of Florida, and they do it in a big way. A lot of large-size materials, lots of material to begin with, a lot of trees for every planting that they do. And these are meant to capture your attention at 70 miles per hour while driving to destinations across the state. It's a sign of care that we hope resonates with tourists and other residents of the state, and it's also something that we hope is an investment for the future. And it appears to be the case given the success rates you had with your transplanting program. A little bit of background information. The Florida Department of Transportation really kind of got into planting in a big way in 2011 with the start of its Bold Initiative. This program features a lot of large installations, like I showed you before, focusing a lot on trees and palms in interchanges, medians, roadsides, and rest areas, the public areas that FDOT manages across the state. As I said, FDOT is a major player in planting in the state. A colleague of mine calculated that FDOT was spending $40 million a year on tree planting and care with the start of this initiative in 2011. So for us, for our research objectives, we wanted to see how early planting program success, how it fared. How did growth and establishment and the health of the trees fare after planting, given the contracts that were in play? And then what we hope to do is tease out any factors that were either degrading tree health or helping them, kind of showing the care that was really effective or not effective in maintaining tree health and vitality. Here's an example of one of the sites that we looked at. This is the I-75 and I-275 interchange near Elton, Florida. What we show here are all the trees that were measured for this particular project. They're color-coded by species, so you can get a sense of the pattern here. And what we did is, since this was such a large planting site, we broke it into one contiguous area, which is the clover leaf that you see in the upper left corner. To get a sense of the scale of some of the plant materials that are used in this particular site, here's a picture from on the ground. This is one of my technicians measuring soil compaction on the site underneath the canopies of the royal palms in the background. It's pretty spectacular. Seth's experimental design, he looked at 21 different projects from across the state, and these were projects that were between 9 and 60 months of age, so essentially just under a year to under 5 years since planting. This gave us a range of things that were still under contract and things that were beyond contract, and we looked at quite a bit of trees throughout all the districts. There are 7 districts in FDOT's territory. There's 6 kind of geographical districts, and then one that's associated with. Actually, there's 7 districts that you're well familiar with, plus the Turnpike, and we visited all those aside from District 6, which was Miami. It was our last stop on the tour as we were going all over the state, and unfortunately Hurricane Irma hit before we could get there, and we didn't want to make it a study on how trees can get damaged by severe weather. Rather, we were hoping to just look at projects that were normally cared for under ideal conditions and what was happening, because we can't control the weather. On that same vein, we avoided projects that had a lot of phoenix species in there. As many of you are well aware, Texas phoenix palm decline, now called lethal bronzing, is a major disease of phoenix species, or the phoenix genus. And we didn't want to show sites that just had severe losses to that disease. Rather, we were showing what would be a typical scenario if proper selection had avoided the use of palms that were susceptible in areas that had lethal bronzing. As I showed you in the last slide, we try to get about 100 trees per project, so that often wasn't an entire project, that was just a portion. These were chosen at random, and we try to keep groupings together. We didn't jump around. We just kind of picked what fell and measured it. So as far as measuring, we measured a lot for this. There's a lot of data collection, both tree-related variables and management-related variables. From the tree, we had two main responses. First, we wanted to look at whether or not the tree was alive or dead, which is kind of a coarse measurement, but it's one that's common in the literature. Because, when you think about it, you need a cutoff for what's living and what's dead, and we chose what most people do, which is any foliage on a tree. If there's just one green leaf, it's considered alive. We wanted a little bit more resolution than that offers, so we also included, just as a first attempt, we haven't really seen this elsewhere, visual ratings. These are numerical ratings, and they're in 20% classes. So 1 is 0 to 20, 2 is 20 to 40, etc. And these are visual assessments of plant health that can be done quickly, and as we found with our results, can actually show some differences, which was pretty important for this project. Finally, we had predictors related to the trees. Species is a major predictor. How do they cope with the sites that are typical for FDOT plantings? We also broke our trees up into type, like shade trees, small stature trees, like your flowering crepe myrtles and things like that, conifers and palms, because they're cared for a little bit differently and they have different demands. So we want to break that up a little bit. And then finally, we had years since planting, hoping that growth and health increases as time goes by, and they overcome the stresses of transplanting. For management variables, we had whether or not onsite irrigation was present. All these trees are, in theory, irrigated, even if it's a water truck. But when you have on-site irrigation, it just makes it that much easier to maintain care and water on the site during dry spells. So we want to see if that had an effect. We also want to see if staking more than 1 year negatively affected tree health, because current guidelines in the industry are to leave stakes for a year or less, if you stake at all, just to prevent curdling from the staking materials. We were curious if planting season mattered, because, understandably, if you plant in the beginning of the wet season, you'd expect trees to do better, because as rainy season hits, they can take advantage of both any irrigation they receive, plus the near daily rains that we often get when things cooperate. And then contrast that with winter, when things tend to be drier, or early spring, where they're both warm and dry, and see how that affects plant survival and health. Root flare indicates, if we see a root flare, we know the tree is planted at the right height. If it's buried, it could be buried a couple inches or more, and deeply planted trees, there are a range of root defects that can be caused from that. On heavy soils, it can actually kill roots because they just get smothered. And so we were looking at that as a predictor of plant health and survival. Finally, was there trunk damage or berms? Trunk damage being related to often lawn mowing equipment, and then berms are just really kind of important, and I'll show you that, especially on a lot of the hills and embankments that overpasses have, for keeping water near the tree where they need to be. In addition, we were really interested in a new system called RUSI, which is the Rapid Urban Site Index, which isn't so rapid when you look at all the things that are in it. But it was a way of just kind of getting to the heart of all the differences in soil that are associated with the different sites, and kind of taking account of that variation. So they look at soil physical structure, texture, how compacted the soil is, how much effort does it take for a root or a probe to penetrate it. We looked at soil biology, which would be the organic material and the space associated with the tree. pH, salinity through EC, soil organic matter, also the climate, growing degree days, crown light exposure, precipitation, and then finally urban sites, were they close to traffic, and all of them were, so we just kind of dropped that. Proximity to infrastructure like roads and barricades, and then what was the cover? What was the surface cover? Was it grass or mulch or other land or ground covers, and how did that affect tree growth? So we tested our dependent variables, both health and survival, in different ways. First, we want to see did the proportion of trees alive differ by different treatments. Well, specifically, because we had a little trouble with our stats, some gaps in the data that made logistic regression hard. We really focused in on onsite irrigation and whether or not that triggered, higher rates of survival or lower rates of survival. And then we looked at the quality and vitality of trees versus all the factors that we showed you before in the big regression model. We looked at lawnmower damage and how that varied by rooting area, mulching, staking, and times of planting. That's a pretty interesting story, and we'll talk about that a little bit later. We included replacements in all of our analyses. So, if a tree dies within the contract period, FDOT makes the contractor replace it. And not only that, but they set the clock over again. So that was an artifact of the data that we just couldn't get around. But the ultimate goal is to get trees established. So we called our dependent variable tree establishment rather than tree survival, because you could have a lot more, or tree mortality, because you'd have a lot more mortality that you weren't even seeing given the replacements. The picture here shows some pretty intense lawnmower damage. This can be pretty severe. This is actually the tree that we met our project manager by in Boca Raton, and these are kind of the incidents that you want to avoid for long-term health and benefits of trees and palms. So some results and discussion for the work that Seth did. First of all, a big pat on the back for FDOT. You had a very high establishment rate. 98% of all the trees that were supposed to be there were there and living 9 to 58 months after planting. This is pretty much the highest that we've seen in the literature. Two studies come close. First is one that my team did again in 2004, where we looked at the planting associated with and survival associated with Florida Forest Service funded granting projects. So Florida Forest Service, like FDOT, has some very high standards for their quality assurance. Trees are replaced by the grant awardee if they die within the establishment period, which is about, I think, 2 years. And again, a very similar climate, because it is Florida. It's the same climate as FDOT sites. So, and all over the state, just like FDOT sites. So, another talk by comparison, or another research by comparison, was work by Lara Roman and her colleagues in 2015. This is a cool study because it was actually done on highways, near highways, these highway plantings in California. They had a very high level of care, just like Florida, and high standards for quality assurance. But given all that, they still didn't reach the 98.5 that FDOT did. They were 96.3. Probably not statistically different, but it's good to be on top, right? So, as I said before, we kind of looked at how survival differed by care, and one of those factors was on-site irrigation, and we found that by and large, it didn't seem to matter whether irrigation came from a truck or from a pipe. The only real difference we saw was in our palms, and we think that was probably driven by the large sample size of sable palmetto, they're pretty sensitive to drought stress. These things are not planted in a nursery generally. They are often harvested wild from swamps in the woods. And when you harvest these things as field-grown trees or wild-grown trees, all of their roots die back to the root initiation zone at the base of their trunk. So that tree or that palm is surviving solely on the water stored in its trunk until it can grow roots back and start taking advantage of soil moisture. And often, the crowns of these things, we'll show you this later in the pruning section, are cut back pretty significantly to prevent desiccation, but maybe that's not sufficient in all cases, and we seem to have seen that in our data. Other aspects of tree health and water management. Tree health, is different than our very coarse measure of survival, so we were able to pick up a little bit more information, and that's important because tree health now, the tree health of a tree today, is a good indication of what's going to happen to the tree in the future. They don't move fast one way or another. The health doesn't fluctuate wildly. Rather, trees either slowly decline, they stay the same, or they can gradually improve over time. So if you see something on a decline, you know that it's in trouble and it could be on its way out, especially if stress factors kind of pile on that thing. So with regard to tree health, not having on-site irrigation actually decreased health. So you were 5 times more likely to drop a rating for our visual measures of health if you didn't have on-site irrigation. And as average annual precipitation decreased, so did your likelihood of being healthy. Wet season planting only seemed to really benefit our palms again, which kind of shows how things can be pretty variable, especially when you have irrigation in the mix. But we did see that as crown light exposure, as the openness of the site increased, health decreased because these things just get baked in the sun, especially when they're newly planted and they're just out there for the first time. Urban health differed by was increased as you moved away from curbs and roadways. So you just have more rooting area when you're not right next to the roadbed because roots cannot penetrate below a roadway. It's just there's too much compaction there. That base layer just is a big barrier for root growth. And that reduced soil access on that side, especially if you're in a cutout or in a small median, can really limit how trees grow in the future. We also saw that estimated root area was either good or bad. It kind of differed depending on the models that we were running and whether we were looking at big trees or small trees. And I think what that was showing is that we weren't really reaching a limit for most trees on how where their roots could go. They weren't getting kind of confined to the point where they were running out of rooting space. And then sometimes health would actually decrease as rooting space increased, and we'll show you that that's kind of linked to lawn mowing in the future. As time went by, trees often increased in health, which is what you want to see. As trees survive and overcome the hardships of planting, you want the health rating to increase, and we were seeing that for most of our species. In contrast, though, palms tend to decrease very slightly. They stayed pretty static, but they decreased so like a 1-to-1 odd is pretty much the same, but there was a slight difference. And I think what that has to say is that palms, they slowly degrade over time if fertilizer does not meet their demands. Palms are the neediest thing in your landscape, and needier than the grass when it comes to fertilization and supplemental nutritional support to prevent deficiencies. And they get all that in the nursery, but as they move to the sandy soils of Florida, you miss some fertilization or you just don't do it at all, they will start to decline over time. And again, like we talked about staking more than 1 year being a negative, because that's generally what it is assumed to be in the literature and industry-wide in our best management practices. But we found that actually leaving stakes on longer, as long as you're not girdling the tree, really increased the health of our trees. Trees that had their stakes on for more than 1 year were 3 times more likely to be healthier, a level up, than those that didn't have the staking more than a year. So again, if you're doing your job, if you're adjusting them, make sure that they're not girdling. Having stakes on the outside of a tree, that's a physical barrier that prevents lawnmower injury. So, speaking of lawnmower damage, this happens to the best of them. Most trees, as they get older, will have some sort of lawnmower damage to their roots, if they're surface roots, or their lower trunk. We found that a lot of the FDOT practices were actually decreasing the likelihood of lawnmowers. This is a model that Seth came up with. It's a logistic regression model. Very clever. He had this data, and he looked, and he found that if you have a mulch ring around the base of a tree, you're 3 times less likely to have damage than a tree that has no mulch, And then if you have stakes on the outside of the tree, either 2 or 3, you are 4 times less likely to have damage from a lawnmower than a tree that doesn't have that staking. So you can have a 7-fold protection if you have both mulch and stakes in place. Again, the stakes can't stay there forever, but if you have them for a year or so, when the tree is youngest and its bark's the thinnest, in many cases, you can really give the tree a leg up. One thing that we found somewhat surprising is as the root area or the spacing between trees increased, the likelihood of having lawnmower damage also increased. But it didn't take long. We talked to FDOT folks, and they put us straight. They said that the more space you have between trees, eventually you get to a point where you start using bigger equipment, which is less maneuverable, like brush hogs on the back of a big tractor, and that increases your likelihood of getting lawnmower damage. So if you design spaces that pretty much necessitate the use of like zero-turn lawnmowers, you can actually protect a lot of your trees because they can't get that big equipment around there and they won't even try. So one thing that was pretty funny is what Seth called the bad day factor. We don't have it here, but if a tree got marked up, essentially the likelihood of the tree next to it getting marked up was even greater. And we call it having the case of the Mondays or whatever, showing up to work and just not having your head in it and just kind of dinging all the trees down the line. So it could be very operator dependent on that. Comparing FDOT to other studies, again, you guys are doing really well. FDOT, we found out of the 1,200 trees that we looked for and categorized lawnmower damage, only 6% of the trees had any sort of damage. Compared that to Justin Morgenroth's work in New Zealand, where he had almost 2/3 of his trees had some sort of lawnmower damage. Mulching was less prevalent there. He also had some older trees in his study. So, if you have a tree that's in the ground for 20, 30 years, that's 20, 30 years of lawn mowing where things can go wrong, right? More representative of what we were doing, Lara Roman looked at lawnmower damage, and again, about the same, but slightly bigger. She had 7.2% of her trees had lawnmower damage in about the same time frame as we did. Other trunk damage beyond just lawnmower damage, We had about 8%, and compared to, this could be vandalism or cars or other kind of marks that just seemed too high to be lawnmowers, but we couldn't attribute the damage to staking or other things. Just Vote looked at trunk damage in hers. This could even be holdovers from planting, and found nearly 1 in 2 trees had some sort of trunk damage, whereas FDOT, you only had 8% in your population. Staking damage, 1%, compared to, as much as 85% by Blaine and Foster in 1978, and 70% for Lombros, or 40% for Roman et al. So we had much less staking damage in Florida with your plantings than others had noticed. Staking more than 1 year was significantly greater in Florida than our other work with Florida Forest Service projects in the state. But again, as long as it's not causing damage and things are being readjusted, that staking actually serves as a deterrent for lawnmower damage. Mulching, which is very good for trees, it prevents damage, like we said. It brings organic material into the soil, can build structure over time as it kind of works in the soil and breaks down and adds organic matter in. There's so many good things about mulching. It keeps weed competition at bay, keeps water from evaporating by the roots, all these things. You guys got the message, and 76% of your trees had mulch, which blows everything else out of the water. 7% for Lou, 40% for Roman, and 10% for Just Vote's work in Chicago and Indiana. That said, a lot of the trees were planted deep in FDOT. And this isn't always a problem, especially in sandy soils. A lot of trees can overcome this. But 1 in 2 trees that FDOT plants is planted so that you cannot see the visible root flare. So some conclusions for this research are that irrigation is important for palm establishment, especially irrigation is important for everything, but having irrigation permanently installed is important for palm establishment. The early replacement strategy and everything else in play are really ensuring a high establishment rate. Again, the highest on record, so give yourselves all a pat on the back. If you take care of your trees, they will respond well, and you guys are demonstrating that to the world. This paper will come out, or it has come out, and folks who read it can hold up your program as kind of like the gold standard, honestly. Visual health ratings show the potential as factors for assessing plant health, and what they are, they have more. You saw that we were able to see a lot more definition in our predictive variables. We got to see their impacts on vitality, and it's kind of a precursor to whether the tree is going to fail and die or live a long and healthy life. So having visual health ratings was really key for this project, and so much so that we're going to have another presentation later that shows you how to do these health ratings so you can assess the performance of your plantings in the future. So finally, that was a lot of science, some numbers, some statistics. We're going to leave this presentation with some case studies showing some of the things that were witnessed by Seth and my other students and myself and everyone else who went out in the field of Seth. And he took some really good pictures, and hopefully these are good insights on things that we saw, not often, but we saw that you can correct for future plantings. First, again, we talked about this picture, lawn care damage. Anything you can do to reduce lawn care damage will go a long way to assuring that the tree has a long and healthy life. This could be, making mulch rings around the trees, staking the trees in a preventative way, like having 2 or 3 stakes around the tree, and just using equipment that maneuvers well between these trees. Here's another picture Seth took. This is some irrigation material that, often you stake this down next to the tree or aside from the tree. Someone decided to save some stakes, planted them in the middle of a multi-stemmed shrub looks like privet. And as the trunks grew and grew into each other, it pinched off that irrigation tube, essentially cutting off water to that tree and all the trees down the line from that. So, trees grow, and just don't place these things in between the trunks or on branch unions. Nursery stakes. So often you'll get a tree from the nursery and it just flops around, and because these things are their growth is pushed to the max in the nursery, and they're staked heavily to keep them from falling over in wind, and they don't develop the taper that they really need to stay up on their own. So it could be tempting, instead of putting your own secondary supports in, to just leave what was on the tree when it was in the container and you got it from the nursery. This is an example that you often see. It's a bamboo rod next to the trunk, and there are some plastic ties that are supposed to be photodegradable, holding the whole thing together. Well, if you can see here, it doesn't take long, maybe a growing season or more, and you've already girdled that tree because of the plastic ties being left in place. So whatever someone says, they will not break down, they will not fall apart. Remove that at planting and use some good staking materials to keep the tree in place and let it move a little bit so that it can actually start developing taper. So this is good staking material. This is wide webbing, which doesn't really abrade the bark, and can kind of it shouldn't girdle the bark if adjusted yearly, and making sure that there's space for tree growth during the growing season. Unfortunately, this Crepe Myrtle here was left staked too long, and you can see that it girdles just like the last image that we had with the nursery ties. So removing these things at least after 2 growing seasons is essential. So I'm not sure how common this is. This is something Seth saw. The staking materials were brought to the site. They actually had some garden hose here that they were going to use to reduce damage to the thin bark on these magnolias, and then they didn't even use them and just put the wires right up against the trunk. So, but on the same point, making sure that you remove all the ties, and often folks will put, pieces of carpet or burlap or something on a trunk to prevent it from getting marked up during transport. These things need to be removed as well. They can girdle the tree. They can, insects and other things can hide underneath them, and you won't even see if there's damage occurring. So removing those coverings of the trunk should happen at planting. So this was something they saw that really got his attention. Was Confederate jasmine. Having a nice ground cover like Confederate jasmine instead of turf can prevent lawnmower damage. But in this case, it started wrapping around the stem of this Crepe Myrtle, and rather than just kind of carefully cutting it, loose, someone took a weed whacker to it and probably hit more tree than vine in this case. So, so transplanting materials. If you have balled and burlap trees, which is more common in the north of the state, there's a couple of growers that really specialize in that up there. They often have someone digs with a hydraulic spade the root system of a tree out of the ground. A lot of the roots are removed, and they want to protect what's left and make sure that they're not being damaged. And they do so by putting burlap around the root system and wires and cinching it all tight, and then putting twine at the top to keep it all together. And there's a debate whether or not these things should be removed at planting or not. All of our research has shown that it really doesn't matter, except for the stuff at the top of the ball. If you have twine that's wrapped all around the trunk of a tree and it's going down and connecting to the wire basket, and you don't remove it, that twine, even if it's natural fibers, will essentially girdle that tree just like all the other ties that we saw before. So remove that. A general rule of thumb that I still stick to is remove all the packaging from balled and burlap materials on the top, third or so of the ball, and you won't have any issues with that in the future. Here's some circling roots on a tree that was planted above grade. So what it's showing here, planting above grade is not a big thing. It's not a problem. It's actually an ideal thing if you have really heavy clay soils. But the problem here is this, tree doesn't have a berm, so even it's the highest thing. You pour water in that thing, and it's going to roll right off into the surrounding soil. And it has circling roots. So this tree was left in its container too long. Those circling roots kind of swirled around, and instead of having spokes on a wheel going out in every direction, anchoring the tree down and kind of really holding it in place, you've got this kind of swirl of roots that will allow the whole tree to kind of pivot like it's in a ball and socket joint. So the solution to this, I would plant trees at grade in Florida. I would make sure they have a berm so the water stays in place. And before you get that tree in the ground, make sure that there aren't any circling roots on the outside of the tree. And if there are, shave them off. Remove the outer 1 inch of the root ball. But also when you see them on the outside, make sure you check further into the ball, because there could be several layers of circling roots for every size container that tree was in when it grew from a seedling to a full-size nursery tree. Keep mulch away from the trunk. Mulch is great. Mulch shouldn't be too deep, as we'll show you in the next couple slides. And it should not be up against the trunk, because all sorts of critters and pests can kind of grow in there. And if you have mice in there or whatever, and they're right up against the trunk, they might just kind of girdle your tree. So, but mulch is more good than bad, and there's a lot of research to show all the good things that mulch does. Just apply it properly. So don't have it piled up against the trunk of the tree. Species selection. Don't use Texas Phoenix, palm decline, or lethal bronzing susceptible species. They will die, and if it's a Phoenix, it's going to be a very big expense, because the trees cost a lot, and they just are super susceptible to lethal bronzing. So. Leaky irrigation, a lot of these systems are kind of pressure regulated. So if you have one of the valves cut off by a lawnmower or broken, that one tree gets a lot of water and nothing else really does. So make sure that that stuff is checked for the good of all the trees. Staking too long. This was a tree, again, that came from the nursery, grew super fast, but wasn't stable to keep itself upright. And when you do the video for this, the thing just wobbles back and forth. You can see that's completely reliant on the cabling. Not only does it cause girdling, but you can see that because the tree was staked so rigidly, it's actually fatter at the top above the staking than it is below, because there's no need for that tree to develop taper. Planting depth. This happens a lot with palms, unfortunately, but it also happens with other trees. Trees often come from the nursery kind of deep in the container or in the ball and burlap. And if that's not addressed and the tree's just planted at the same level, they will enter the landscape planted too deeply, which can cause root defects and can cause smothering of roots and all the things I mentioned before. Palms, it's a special kind of problem for them, in that people think they can just plant the palms at whatever height they need to either make a uniform row. So sometimes you get palms that are taller and shorter because they come from different sources or they were wild harvested, and you want it really even. So you plant some deep, you plant some high, and the ones that are planted deep suffer, as you can see in that picture right here. So making sure that you plant at the appropriate height, which is at the root flare on trees and at the root initiation zone for palms, can prevent a lot of problems in the future. Here's a picture of erosion. A lot of these things are on hills, so if you don't have mulch in place, if you don't have berms in place, when the rain comes or when people irrigate, all the soil can just kind of roll down the hill, and then you have an exposed root ball, which is a problem, because root balls, especially if they're container trees, have a lot of organic material, and when that stuff dries out, it's really hard for that root ball to re-wet again. So keeping them covered by soil and by mulch prevents that from happening. Oops, went the wrong way. Mulch depth. So here's a couple of palms down in South Florida that just have an overabundance of mulch around them. The temptation is to put a lot of mulch down so you don't have to come back, because it does wash away, especially if it's not a heavier mulch like cypress. Also, it breaks down really quickly. We have a humid, hot environment, and that microbial action takes place, and this stuff could go down pretty quick. The problem is, until it goes down, you're smothering the roots of that tree and making it hard for them to grow into the surrounding environment. Berms, showing you here how effective they can be. If you didn't have those berms here, the water would just go straight down on the side of that embankment. But because you have berms, water can stick in place, and it's almost like a little dam in these cases, keeping the water on that hillside so that the palms can soak it up. Soil amendments. This was a case that really got Seth's attention. This was a planting strip that had been filled with some really good soil, and the palms and everything else looked really good. So if you have sites that are, pretty much all roadbed, small medians, rather than using whatever fill is left over from regrading and all that stuff, you actually take out the soil and put some good quality topsoil in there, you can have some really good results and not fight with fertilizers and things for a long time. So, this is pretty cool. So Ed Gilman a long time ago, a couple years ago, showed that one of the most effective means for staking trees is to make what it's essentially like a giant staple. You put some wooden dowels or some small sections of like 1x1s, and you those serve as like the stakes, and then you kind of go over those with a 2x4 or a piece of wood to kind of press down on the roots, and you can essentially staple large sections of the roots down, and it's a very strong way of keeping trees upright in wind, and it's not a very visual thing that will be an eyesore in the future. And because if you use untreated wood, this will break down before it causes problems with the root system. If it's all untreated wood, this shows a metal strap holding everything together, and that metal strap will not degrade in time, and those roots will be partially girdled from that design right there. So if you're going to do root ball staking, it's really cool and very effective. Look at the work that Gilman did, but make sure that you have all biodegradable materials in your system. Drought stress. You can see a lot of plants that have drought stress, like bald cypress and other things, will start shedding leaves early, and that's a sign of just limited water conditions. The tree's losing too much water, can't justify keeping this canopy in place, and it's giving up for the season, hoping that things get better the next time around. Unfortunately, trees have a very ability to kind of cope with the stress. And if you see signs of drought stress, often it's too late to prevent losses of growth for that growing season. So the best bet is to just kind of make sure that you don't get to this point with your trees. Bracing, these should be removed over time. Often they can be left too long on palms, and this kind of bracing really shouldn't be used for any kind of like shade tree or anything that will grow bigger in diameter, because it'll cause deformities in the trunk and could partially girdle the trunk, right? So I'll just put these slides up here for your viewing. Seth also showed a range of the diseases and pests that he saw in the field. Pretty much all these are minor players, mostly cosmetic, but he just figured he'd do that just so you could see what's kind of attacking your plants. Again, really nothing too serious. Ganoderma. So yeah, a root rot fungus. These can be pretty serious, and when you see conchs like this is a potential health and safety hazard. kind of show you. Seth also had some graphs kind of showing how soils differed over location. Your subtropical species having a worse or a better RUSI score, a better score with regard to soil organic matter than the ones further north. Saltier, just the breakdown for your soil textures between loam and loamy sand, sandy loam. A lot of sand in Florida. So I'll just leave you that. This is a picture of Seth in the upper left. He did all this work. He put a lot of heart and soul in it. He's a very smart student, and you have a report that you should be proud of, and others can use to replicate your successes. So I thank you for that. Again, this was our one really research-heavy presentation. The rest is more applied, but this is what the research office paid for, and it kind of, like I said, it's a big pat on the back for FDOT and all of its efforts. So